This is Unit 2, Segments, Lines, and Angles, Preview Video 2.1, the graphing of lines. Take a moment. You're going to sit tall, ready, inhale. Exhale, 5. Don't skip this step. Get your brain ready to think. Ready, inhale. Exhale, 5. Shoulders. Close your eyes, inhale. Hold. Exhale, 5. Breath. All right, let's go. Taking a look here, don't forget the date, time, and location, as well as a parent or guardian sign-off affirming of your diligent viewing of this video. Digging out my pen here. You're going to need a straight edge today, so make sure you have a straight edge of some sort, Hannah. So it doesn't have to be a really big straight edge, just something to draw straight lines with. All right, today is going to be a bit of a review. So do me a favor, no calculator, run through these radical problems, pause the video. All right, welcome back. You should have a red pen handy. You are correcting your work. Star smiley if you are correct. Some sort of written note if you are not correct. And what belongs here? 5 root 5. Root 5 times root 5 is 5. 4 times 5, this should be 20. Root 3 times root 3, 8 times 3, that's 24. Root 6 times what is 6? That's simply another root 6. And this one will be root 5, because root 5 times root 5 is 5. 2 times 5 is 10. All right. What are we doing today? We're going to be graphing of lines. Most of this should feel like a review. We're going to talk about something called rate and slope, which are actually interchangeable. Y-intercept, x-intercept, slope-intercept form of an equation, and point slope. You're going to need a straight edge, your pencil, and a red pen. Slope is simply the change of the rise over the change of the run. Change of the rise over change of the run. In science class, the word change or difference is going to be used with this symbol. That means change of, or it's called delta rise. It's the change of the rise and the change of the run. Rise, for example, if this would be slope, like this, just trace it. The rise would be the amount vertical compared to the amount horizontal for this line. Rise over run. There's 4 different kinds of slopes you need to be familiar with: positive, negative, zero slope, and no slope. First off, we read all graphs from left to right. So I want you to put your left arm up, like so. Tap it, say left, drag it, say right. Left to right. Ready? Tilt your arm upward. That's positive. Left to right. Tilt your arm downward. Say negative. Left to right. Horizontal. Say zero slope. And vertical, say undefined. Ready? Tilt your arm. Let's do it again. Positive, negative, zero slope, undefined. Do it again. Positive, negative, zero slope, undefined. Let me explain. A positive slope, of course, tilts upward from left to right. And let's go ahead. We're going to find the slope here. We're going to do rise over run. We're going to bunny hop it. So from this point, our rise to our run 5. So our slope would be positive 2/5. You could also go this way, 2 and 5. Same thing, 2/5. Now, some of you were like, well, Miss Way, we went down, so it had to be negative, and we went left, you have to be negative. And sure, that's the technical way. But a lot of students get confused when I'm counting. Do I go positive? Do I go negative? And they mix up all their signs. Really simple. Forget counting positive, negative, up, down, left, right. Just forget about it. Look at the entire physical line itself. If it's tilting upward from left to right, it is a positive slope. Let's do this one. Bunny hop, our rise is 4. Our run is 3. You're like, but Miss Way, technically we went down, so it has to be negative. We went to the right, it has to be positive. That's fine. If you want to keep track of that technical stuff, you can. But in my mind, the easier way is going to be this. Or I could have done rise this way. 4, 3. Either way, my slope is going to be here. Slope is 4/3. However, I go down from left to right, down from left to right. So that is a negative slope. I am going downward from left to right. Positive slope, upward left to right, downward left to right. And remember, it's rise over run. A completely horizontal line has 0 rise. It has 0 up or down motion, but it does have a number in the run. We know 0 over anything is just 0. So a horizontal line has 0 slope. Horizontal line, 0 slope. So the way I remember it is I make a 0 like this, make my arm horizontal like you're looking through a spyglass, 0 slope. 0 is a number. 0 over anything is just 0. For a vertical line, you have a number for the rise, but there's no left or right motion. There's no run. There's a 0 in the denominator. When we say in math, only God gets to divide by 0. You can't mathematically divide by 0. So because there's a 0 in the denominator here, we do not call that 0. We call a vertical line undefined. Or sometimes we also say no slope. No slope and 0 slope are not equivalent. Be very careful with that. So undefined. The way I remember that is I make a U in ASL, that's a U, and the U is vertical, so it is undefined. Couple other terms. I want you to just physically trace this line from left to right. Just trace it. darken where it intersects the y-axis, darken that. So we would say the y-intercept right there is going to be 0, -3. Follow it along. It intercepts the x-axis at 4, so that x-intercept is 4, 0. When you do coordinate points, just as a quick review, the first coordinate is x, second coordinate is y, horizontal is x, vertical is y. Graphing vertical and horizontal lines. Let me tell you what this is not. Watch carefully. X equals -3. 1, 2, 3. X equals -3. Ta-da! No. Careful. This does not read x equals -3. What I just did right here is -3, 0. It's a singular point. This reads like this: all points where x is -3, something. All the points where. So when you see x equals -3, you ask yourself, where are all the points where x is -3? Well, -3, 0 is one of those points, but so is -3, 1, -3, 2, -3, 3, -3, 4, -3, 5, -3, 6, -3, -1, etc. So x equals -3 is a vertical line, all the points where x is -3. So x equals 5 is all the points where x is 5 and y is something. So 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, etc. You just work it up. It is a vertical line. All the points where x is -5. X equals 8, all the points where you have 8, something. So 8, 0, 8, 1, 8, 2, 8, 3, 8, 4, 8, 5, etc. X equals 8. It's +5 up there. So here, x equals 8 is a vertical line, and the slope here is undefined. We're going to graph now a line. Line is where you have a y and an x, and technically the exponent for both of these is 1. The minute you get into x squared or y squared, things start curving. That's algebra 2. We're not going to worry about it for the moment anyways. So right here, a slope intercept equation of a line is what you commonly know as y equals mx plus b. B is the y-intercept. Step number 1 is we identify what our b, you write the equation. Always write the equation directly underneath, always. Number 2, we're going to identify what is our y-intercept right here, and we're just going to write it down. Step 2, we are going to identify our slope. Remember, it's rise over run. So our rise, -3, and you're like, there is no run. Aha, but there is, because technically, super important, all slope, without exception, are fractions. All slopes are fractions. So even when you're given a whole number, you need to pop it over 1. This is our slope. And it is rise over run. Rise over run. So to graph this, step 1 is you identify your y-intercept. Y-intercept is on the y-axis. So we go down the y-axis and we pop a 3. That's our anchor point. Now, we establish this is a negative slope, which means with your left arm, this is going to tilt downward from left to right. So I'm going to make a little baby icon here. My line needs to go that way because it's negative. So my rise is 3. 1, 2, 3. My run is 1. You're like, wait a minute, Miss Way, you went up and it's supposed to be negative. It's supposed to go down. It doesn't matter. What matters is your final product tilts downward. So I can go up 3 and I'm going to keep my colors straight. I'm using green for rise and left 1, or I could go down 3 and to the right 1. What matters is the final resulting line tilts downward from left to right. That's what matters. Which way you count it, up or down, does not matter. What does matter is that the resulting line is going to tilt downward from left to right. Start by writing your equation, y equals mx plus b. And we go here. And we're like, where's the b? Well, when there's nothing there, your b is 0. Your y-intercept's 0. And here our slope is going to be 5 over 3. So my rise is 5. My run is 3. It's a positive line, so I'm going to go upwards from left to right. Upwards from left to right. Okay, I can either go up 5 and to the right 3 or down 5 and left 3, but either way, I must have a positive tilting line. Now you take your straight edge and here you go. It's a positive line going up from left to right, going through the y-intercept of 0. Now, sometimes it is not in y equals mx plus b, and in that case, you have to get y by itself before you can do anything else. So we need to get y by itself. So here, everyone's trying to get away from y, so I'm going to add the 2x, add 2x. I'm going to cancel. I'm going to add the 10 and add the 10. Cancel. I'm going to switch it around so it's a little bit more familiar here. Negative 5y equals, this is a couple and a single. Couples and singles do not mix and mingle. So that is not 12x, that's 2x plus 10. Last but not least, we get rid of the -5 by opposite of multiplying is dividing. And we get our final version here, which is y equals -2/5 x minus 2. Right underneath, I'm going to write y equals mx plus b. So our b is going to be -2. That's where it crosses the y-axis. So that's 0, -2. Our slope, our rise is -2. Our run is 5. So I know that it must go downward from left to right. So from here, I'm going to rise 2 and run left going 5. 1, 2, 3, 4, 5. Or I can drop 2 from the same point and go to the right 5. 1, 2, 3, 4, 5. But either way, I get a downward tilting line from left to right. All right, these 2 pages are yours. Try to do them on your own. These 2 pages. Pause the video. All right, students, welcome back. You know, doing, trying, and then correcting is a learning experience. Copying is not a learning experience. So hopefully you actually paused the video, did your own work, and now you have your red pen handy. And so I'm not going to explain it. I'm just going to zoom through the answers because you should have done the work. Y equals -6 looks like this. All the points where there is a something -6. So that would be like 0, -6, 1, -6, 2, -6, 3, -6. So y equals -6 is a horizontal line at -6. That's y equals -6. And the slope here is 0. Y equals 3 is all the points where there's something, 3. So 0, 3, 1, 3, 2, 3, 4, 3, etc. That is a horizontal line. Y. Y equals 3. Again, the slope is 0. Y equals 7. That's all the points where there is a something, 7. So 0, 7, 1, 7, 2, 7, 3, 7. So y equals 7, horizontal line at 7. Slope here is 0. Correcting your work, not copying. Y equals mx plus b. Our b here is 5. 1, 2, 3, 4, 5 right there. That's going to be 0, 5. And our rise 3, our run is 2, and I have a negative line, so I know it's going to go down from left to right. So 1, 2, 3. 1, 2. Or 1, 2, 3. 1, 2, this way. There's no rule that says you have to stay on the graph. And that is y equals -3 over 2x plus 5. All right, now we're going to show, like, why do we need lines? Why do we need to be able to graph lines? Well, graphs, lines, and eventually parabolas, they're predictors. They can be used as analysis of what is and a prediction of what may be. So it's utilized a lot in finances. Let's do this problem together. You have a loan of $1,200. in debt. After 3 months, you owe $800. At this rate, how long will it take to pay off the debt? Graph and express this problem and equation of a line y equals mx plus b, graph using a straight edge. Now, the first thing you need to understand in graphing is we arrange graphs with independent and dependent variables. Independent versus dependent variables. Independent is the horizontal line. It's known as the cause. Dependent is the vertical line. It's known as the effect. Cause and effect. So when you're trying to determine what part of this storyline is independent versus dependent, just ask yourself, what causes what? And in this storyline, what is changing is the debt. What is changing is the debt. And in this case, that is the amount of money owed. Okay, that's the effect. That's the y coordinate. What is the cause is time, the passage of time, and of course, a repayment schedule. So the independent variable is the x, dependent variable is the y. Think cause and effect. In this case, our cause is passage of time, and the effect is the change in debt. All right. So we start at 0 time at $1,200 in debt. So at our 0 timeline, we are here in $1,200. We are in debt, so technically we're in the negative. So $1,200. That's our starting point. That is 0 time. Right here, after 3 months, we owe $800. So we count 3 months, 1, 2, 3 months, we owe $800. And what it's asking is, at what point will you hit 0 debt? And 0 debt would be represented by our baseline. 0 debt would be, when does this line cross the x-axis? Because that's our time factor. So there's 2 ways we're going to do this. We're going to physically graph it, and then we're going to check to see mathematically how accurate our graph was. So we get our straight edge, and we are going to extrapolate between these 2 points, and we're predicting where does it cross the 0 point right here, and it looks like it is 9 months to pull off this debt. Now, what would that equation of a line look like? It's going to look like this. We can bunny hop our slope. Our units here are by the hundreds, so 1, 2, 3, 4, 1, 2, 3. So it's 4/3. So our slope here is going to be 4/3. And our intercept is 0, negative 1,200. So the equation of this line is going to be y equals 4/3 x minus 1,200. And the question is, what is the time? Time would be the x when the money, the debt, becomes 0. So we're asking ourselves, what is the value of x when y becomes 0? So we solve here. Let's get y by itself. We're going to add 1,200. End up with 1,200 equals 4/3 x. Multiply by the reciprocal. Multiply by the reciprocal. Cancel. 4 goes into 12 3 times. Technically, that is forgot our rise here is not by units, it's by hundreds. So technically our rise there is 400. So it's 400, not 4. Let's backtrack just a little bit. Forgot to add the zeros because it's 400, not 4, because it was between 1,200 and 800. So the difference is 400. So we still add the 1,200 both sides. So I got 1,200 equals 400 over 3x. Multiply by the reciprocal, 3 over 400, 3 over 400. This cancels. Zeros cancel, 4 goes in there 3 times. 3 times 3 is 9. So 9 equals x. So at the 9-month threshold, there should be 0 debt left. You look at your line, and if you graphed it accurately, the 9 is right there. So the graphing of a line enables you to predict something based on the given information. Don't forget to summarize the key points to this lesson.